Good afternoon, good morning, good evening, and a warm welcome to our third climate change webinar series. We faced another extreme year in 2023. According to a recent study from NASA, I think published actually last week, we had the hottest summer on record. And many of you probably remember some of those events. We had droughts almost all over the world. We had in South America, we had in the US, also here in Europe and in Africa. We also had some severe storms in Greece and Italy, for example. And of course, all these events had major impacts on agricultural areas. So today, we will therefore focus on climate change impacts on crops through the lens of reinsurance, crop reinsurance. And I'm very happy that we have two so renowned speakers with us today in the studio. And I would like to say welcome to Jonas Jägermeier, who is Associate Research Scientist at the Columbia University and also a NASA collaborator. We also have my dear colleague Stefanos Mistakidis, who is risk analyst and modeler at Swiss Re, also responsible for our crop modeling at Swiss Re. Before I leave the floor and I let these gentlemen entertain you, I would just like to make you aware of some very simple housekeeping rules to make this an enjoyable session. So first of all, we are applying the Chatham House rules, which means that you're free to share whatever information that you receive here today during the webinar, but you're not allowed to share the identity or the affiliation of who said what. We will also afterwards make a recording of the presentation available. However, we will not share the Q&A session. But with that said, of course, we welcome a lot of questions from you out there in the audience. And you can simply post them by going to the Q&A function. You find the Q&A symbol in the top right corner of your screen. And please, along as we go, post any questions there. And we hope that we can answer as many as possible of them before we end around 3:45. I would also like to make you aware of our very short antitrust statement. So all participants in this event are committed to strict adherence to all applicable competition laws and have agreed to conduct this meeting in accordance with these laws. There shall be no exchange of commercially sensitive information in this event. So without further ado, I would like to leave the floor to you, Jonas. And first of all, we will speak a lot about AGMIP in this webinar. So why don't we start with you sharing a little bit about AGMIP and its purpose?
Sure. Thank you so much, Johan, for having me and for the kind introduction. So in AGMIP, we are trying to formalize climate impact science. It stands for the Agricultural Model Improvement and Intercomparison Project. We're 1,000+ scientists working on climate change and agricultural food system questions. And we're using models, crop growth models, to translate climate science, climate signal, into societal impacts. We have a series of initiatives within AGMIP that you see on the graph, and I lead the global modeling initiative here, which is also coordinated with a cross-sectoral initiative called ECMIP, yet another acronym, it's a mouthful, but we're trying to expand and look beyond just agriculture to different societal impact themes. I want to mention that Cynthia Rosenzweig was the laureate of the 2022 World Food Prize. And it's important for the whole community because crop modeling was for the first time honored at that level, puts it at a stage that is important for all of us and really emphasizes the stake that we're doing with the crop modeling, looking into the future, highlighting some of the impacts that are around the corner.
Thanks so much, Jonas. Stefanos, if we speak about Swiss Re, could you tell us a little bit about how we use process-based crop models?
Sure, Johan. Well, we are using crop growth models to better inform our underwriting decision making. Crop growth models are complementary tools to our expert judgment and market knowledge that help us shape an independent risk view and perception by deriving insights that are not available in observations. And we have developed in-house skills in crop growth modeling because we have identified issues to risk assessment, to crop risk assessment that are, to be honest, common amongst agri-reinsurers globally. Typically, crop risk assessment in the context of our business relies on backward-looking views, based, for example, on official yield statistics that cover the last 10 or 20 years. However, such short time series might not be fully representative of the contemporary and historical risk landscape, while they may also not be representative of today's situation because they include the effect of changes in management practices that change over time. So what we do at Swiss Re is something really cool, among other cool things that we do at Swiss Re. So we run the models backwards in time, aiming at producing long as-if yield time series representative of today's situation. What we try to do is to quantify the as-if impact of historical extreme weather events if they were to occur today. This could be, for example, the compound heat wave and drought in 2003 in Europe, the catastrophic drought in 2012 in the US, past major ENSO events, and many others. We also know that very short time series are actually poor at representing catastrophic crop yield losses. So what we also do with the crop models is we try to quantify the impact of, let's call them forgotten catastrophes, such as the 1976 drought in Europe, for example, or to better contextualize recent catastrophic events and better assess their rarity. For example, you've mentioned earlier South America, Johan. So we look, for example, at the recent droughts that affect major soybean production areas in parts of South America over the last 2 or 3 years. So with all these steps, we can debias our backward-looking view and improve significantly its representativeness. However, this is only half of our homework because backward-looking views may no longer be representative of the future. So what we also do is that we use crop growth models in our forward-looking scenarios where we try to quantify the impact of a range of physically plausible climate unfolding trajectories on crops in order to better anticipate the future. But I think for the future, maybe it would be wise that we first listen to the science.
Yeah, of course. Thank you so much, Stefanos. And back to you, Jonas. And I was just going to ask something in lines with that, Stefanos. So for the AgMIP models then, what do they say about the future changes in crop yields?
Okay. Yeah, let me start by saying it's complicated. Yeah, so it's one thing to say it's going to be 2 degrees warmer in a certain region, or what are the impacts across agro-ecoregions, across agro-ecosystems, across regions, right? So what we're looking at here is an animation by the NASA News team based on recent results we published. And that's in fact the largest ensemble of crop growth models available today, 12 global models run by 5 latest climate models for different climate scenarios. And we immediately see the differences between crops, but also between regions. So that's, there's a lot of uncertainty behind these simulations, but it is important to use an ensemble, multiple models to really reduce the uncertainty. The 3 main findings that came up in that recent publication is, first, the climate signal is stronger than previously anticipated. Second, the impacts occur sooner than we previously thought of. And third, there's a strong latitudinal gradient. So we can't really see it on the maps, but if you integrate the impacts across latitudinal bands, you see that largest impacts happen at lower latitudes, tropical, subtropical regions, which have lower adaptation capacity. So that's a really important finding. And in IPCC language, that's a reason for concern.
And sorry to interrupt. So can you also elaborate on possible changes in the variability, in yield variability?
Yeah. So mean changes is one thing. But it's really important to notice that there is interannual variability that is going to change. And not just in regions where we see yield declines, where more extreme events happen, right? But even in areas where we see yield increases. So that's what this graph shows. the CV, the coefficient of variation, goes up even in regions and crops that have global gains. And the maps illustrate that in major breadbasket regions, especially in the global south, we see increases in variability which can destabilize the food system and can pose problems not just for the farmer, for the insurances, for the stakeholders, but destabilize markets and food systems in general.
I think that's very interesting findings. Stefanos, if you look at the insurance industry and the reinsurance, what do you say about these findings?
Well,
what can we learn?
Well, my first take home is that climate change makes our industry more relevant. At the same time, it challenges the industry's risk perception that, as I explained earlier, is often based on backward-looking views. The results presented just by Jonas show major changes in both mean yield levels and yield variabilities, and they call for transformative changes to crop risk assessment. They highlight the need to the industry to develop forward-looking scenarios in order to better anticipate the future. At Swiss Re, we always argue that crop re and insurers shall assess the representativeness of the loss models that are used of the loss distributions that are used by their costing models, and whenever necessary, terms and conditions shall be adjusted such that they better reflect the changing risk landscape. This is one thing. I also believe that the findings from AgMAP are relevant to portfolio steering, because at the end of the day, our core business is to take and diversify risks. And by simply adding geographical distance to portfolios doesn't necessarily improve diversification. So agro portfolio owners need to closely monitor changes in mean yield levels, changes in variability, as presented by Jonas, but also changes in the speed of those changes, and then factor them into their portfolio steering approach with the purpose, of course, of hopefully growing more balanced and diversified portfolios. We pay particular attention to the concept of the speed of the change, because in fast-changing environments, the risk is high that the industry wrongly assesses the true risk profile. We also find it imperative that crop risk assessment should not lack reality, and that long-term rating adequacy is ensured, especially in areas experiencing rapid and intensifying changes in weather and climate extremes.
Mm-hmm. Return times is another metric we're using.
Mm-hmm. Okay, so we spoke about, you mentioned changes in average yields and variability, but there must be also some other considerations to make. So if you pick a few others, what would you mention?
Well, there's a lot. We can give a whole lecture on impact, but I would like to highlight one particular metric that we came up with in our recent publication: the time of emergence. And the time of emergence has been used in the climate sciences, but not in the impact sciences. It means it looks at the problem from a risk perspective. So it perfectly links to what Stefanos just said. When the mean signal leaves the envelope of historical variability or noise, we speak of a new norm. And that's locally relevant, because 5% changes in one area mean something very different to another area where, for example, you have a very high variability in your system already. So as the graph shows, we have this envelope of historical variability. When the mean signal leaves that, we speak of a new norm. Now these new simulations indicate that that state is, according to these simulations, reached very soon for maize global level within the next 10 years. That's around the corner and hasn't been anticipated before. For wheat, on the other side, we see increases. So the global production and global productivity of yields may actually benefit to some extent from climate change, which is a difficult message to disseminate, but that's what the models indicate, and that the time of emergence actually happens now, within the next couple of years. Now, if we look at these graphs, we also need to talk about uncertainty. We see that large envelope of background noise, and that's something that needs to be talked about when we talk about these results. Uncertainties multiply from climate model uncertainties climate scenario uncertainty, but especially the crop models introduce the largest amount from structural, from input, from management, a lack of management data. So as we see for wheat, the results level off at the mid-century. So there's a lot of homework to be done. And if we have time later, we can talk about specifics, but especially the uncertainty is important to mention.
Mm-hmm.
Thanks, Jonas. Stefanos, if we look at it through the lens of the reinsurer, then how should we as reinsurer interpret these ranges?
Do you notice that his questions get tougher and tougher? Especially the questions that I'm supposed to answer. So, in my view, the large range in the projections is not necessarily a limitation. Mm-hmm. And in fact, it can be relevant to crop risk assessment, given that it is realistic, or if you like, given that it realistically samples the plausibility space, because at the end of the day, it represents a range of potential outcomes. And if I look at our industry, we ensure uncertainty and not certainty. So crop risk assessments shall be prepared and reflect a range of possible scenarios. Besides, deterministic assessments of the impacts of climate change on crop yields can be sometimes misleading in our industry because, for example, they might miss the low probability, high impact events. Even in areas where the majority, or let's say, even in areas where all models agree on the sign of the change, yet the range in the absolute magnitude of this change can vary significantly between the models. So what I think is important for the industry is to build confidence in the range of the projections. And there I believe that validation of models, validation of model input, output, as well as validation of the underlying assumptions will certainly help towards this direction. Besides, we know that validation is a fundamental exercise in crop modeling that also helps us to better interpret the results. And what we do at Swiss Re is that we regularly validate and update our models such that we ensure that their estimates remain fit for purpose. Mm-hmm. Hope it's clear.
Yeah.
If I may, let me interject quick, because I think we still have a minute. Validating a model, now it's getting a little detailed, but bear with me. If we validate a model in historical performance, it doesn't necessarily mean it's fit for purpose to look into the future, right? So that's actually a frontier of our current research. How can we find metrics that inspire confidence, that let us find a way to build a more robust ensemble to narrow, to constrain the model outlooks? And there's a lot to be said, but I want to finish and then we finish on the uncertainty part. It's also an institutional problem, right? So if you look at the climate sciences, a whole institute develops and maintains a climate model. Met Office or NASA, GIS, where I work, dozens, if not hundreds of employees work and maintain on a single climate model. For the impact side, it's a very different environment. I have a postdoc and a PhD student. They leave undocumented code behind. And it's just it's not professionalized in the same way, and the effort and funding, not least, is very different. So I say it again: there needs to be a lot of homework needs to be done, but I like the approach of using the uncertainty in a constructive way.
Yeah, but this is also one of the reasons why we decided to develop in-house skills in crop modeling, so that we also do the updates and validation continuously. So it's a continuous exercise that we do since years, and hopefully we continue doing it in the future.
Thanks, and valid point, Jonas, and thanks for bringing it up. To even out the score, Stefanos feels that the questions gets tougher on him. So let's see if you think this one is a tough one. But now I want to really talk about extreme event attribution. Mm-hmm. And especially, is it possible to see a link between climate change and some of the extreme yield anomalies that we see?
Right. No, that's a good point. Let me switch. I do have a graph on that. So event attribution in climate impact science or in agriculture is notoriously difficult. attributing climate or weather phenomena is one thing, but attributing the impact side, a heat wave, a drought, a flood, hail event, that's a whole different story. And that's actually the forefront of what we're currently doing. We have an ongoing project where we try to get to the bottom of that. So here's a figure that I would like to walk you through. It's a composite of all the historical heat waves that were recorded as a disaster. We put them on top of each other, averaged the impact. So the gray line shows the observations, FAO yield statistics, minus 11.6% historically. So that's the average impact in global agriculture for heat waves. Now, if we use the models and try to simulate a factual, as is, observational impacts, and a counterfactual, so a history without climate change, we use a weather forcing that doesn't know about anthropogenic climate change, we indeed see a difference. So the yellow line is the simulations without climate change, and the green line is the simulations with climate change. And without climate change, the impacts of heat waves are not zero. Heat waves still affect agriculture, but they're less severe. So this is a first first estimate to quantify the climate change impacts in heat waves. But when we look at droughts, this exercise doesn't really work as well. And there's a couple of reasons why that could be. The models may not be up to speed. Droughts may happen outside of the growing season. There's a lot of things. But as I'm saying, it's an ongoing project. And we will publish the results soon, but I'm excited to show a couple of first insights and get to your tricky questions. But this is what we're currently doing.
Okay, thank you very much. Thank you very much. Well, Stefanos, I wanted to ask you, maybe this is a stupid question, and you can obviously answer yes or no to it, but we have time, so don't worry, you can elaborate a little bit. But when you listen to this, is it relevant also for the reinsurance industry?
First of all, I don't think there are stupid questions.
Oh, thank you.
And now I have the impression that you want to dive into deep waters. But seriously, this is a common question actually to us. And usually when I try to explain the topic of extreme event attribution to others, I liken the occurrence of an extreme weather event to a cocktail of many different causes. One of them can indeed be anthropogenic climate change, but others may include natural climate variability, the state of the ocean, land-climate interactions, atmospheric circulation, local pollution, irrigation, and many others. In principle, it is of interest to us to know the contribution of climate change to, independent of cause, to a specific extreme weather event. In that respect, we rely on academic research in the field of extreme event attribution that tries to answer this question for some perils and in some geographies. However, even if we knew the answer to this question, then it is very difficult and challenging to factor it into our decision-making, underwriting decision-making, or into our costing models. Actually, crop re and insurers should benefit from an answer to a slightly different question, and that is to what extent climate change alters the frequency and severity of specific events and impacts. Let me give you an example. Let's assume that in my current portfolio, I'm using random numbers. I expect every 50 years a 20% maize yield loss. Now, going forward, shall I still expect that my 1 in 50 year event results in 20% loss in the context of climate change? Or shall I expect a 20% loss every 50 years? And in fact, the answers to these questions can give us tangible insights that we can use to adjust our costing models accordingly. And that is where I believe that crop growth models and forward-looking views can really help a lot towards this direction. Mm-hmm. Hope it's clear.
It is. Thanks, Stefanos.
Also, I hope it's clear to the audience.
Yeah. Otherwise, it will show in the Q&A later. And I think we have time for one more question, or at least to touch on one more topic before we move into the Q&A. And let me just take the time to remind you, go to the top right corner of the screen, click on the Q&A symbol, and please ask our experts anything that you would like to know, and they will enlighten you. But I think, of course, what we have to touch upon before we move into the Q&A and listen to the questions, it's the question about adaptation and mitigation. So I go with you first, Jonas. How can farmers adapt and mitigate to the impacts of climate change?
Yeah. No, really important. Thanks for bringing this up. We started right into climate change impacts, the response in the global agriculture, without highlighting that all these efforts, all these model setups are meant to isolate the climate signal. We deliberately try to not simulate any adaptation because we want to understand how the current system is reacting to new climate realities, right? But that's not the end of the story. So there is a lot of things we can do in the food system in total, but a lot of things the farmer can do as well. So let me show one last slide. And let me start off by saying that adaptation is only half of the story. We really need to think of adaptation and mitigation in the same breath. If we talk about climate change, agriculture and the food system in general contribute 30% of global greenhouse gas emissions. So we're not, we're not getting around climate change without talking about the food system, which is one of the hardest sectors to decarbonize. So mitigation on the side for a second. There's a lot we can do to adapt to new climate realities. And I'm just flashing here a recent study by a colleague, Sarah Minoli, that evaluates how farm-level adaptation measures can actually buffer some of the adverse impacts. And that is shifting in planting dates, that is applying new cultivars that can exploit a warmer season, a longer growing season, a slower maturing cultivars. But we see limitations. So these bars showing up here are in the range of 10, 15, maybe 20% globally for certain crops. So part of the declines we see in, for example, maize productivity can be buffered. But then if we look at the map, we see that the largest potential to adapt to new climate realities are actually situated at higher latitudes. So as initially pointed out, the lower latitudes, tropical, subtropical systems that are often characterized by smallholder farming, subsistence farming in lower income countries do show much lower potential to adapt. And again, that's a reason for concern, a disproportionate impact of climate change that the global north in a developed breadbasket region can potentially much better adapt to than systems that are operating at warmer thresholds closer to the temperature maximum already. So that's a big problem in the adaptation space.
Thanks, Jonas. Stefanos, adaptation and mitigation measures, what do you say about that? And do they impose any challenges for a reinsurer, or what's your take on that?
Well, I always say that adaptation and mitigation were both born to strengthen the resilience of agricultural systems to the impacts of climate change. And I would say that the list of adaptation and mitigation measures is non-exhaustive. Technology certainly plays a role, and they depend on the peril to be addressed, but also on the crop and region-specific risk profile. In my view, it is encouraging to see adaptation and mitigation efforts out there. However, it is imperative that prior implementation, the environmental impact, the economic sustainability, and the true effectiveness of any proposed adaptation and mitigation measure are carefully assessed and quantified. Then, in principle, our industry, or the crop reinsurance industry, should kick in once best and meaningful agronomic practices are in place. Then they can strengthen the resilience of agricultural systems by covering random and unpredictable losses caused by events or by perils that the industry can model explicitly. However, we also believe that the industry has a role to play in the transition by covering, for example, risks during the adaptation process. In that respect, we will benefit, or the whole industry will benefit from data that are representative of the new environments. By the way, the crop re and insurance industry should also benefit from data available at a high granularity in order to better assess changes in vulnerabilities and impacts on crops caused by perils with a highly localized nature and impacts such as frost or hail. I believe that such data challenges can be at least partially addressed through strengthened discussions, and why not collaborations with other players along the food value chain, such as input suppliers, fertilizer companies, seeding companies, of course with academia, in order to help us bridge this data gap in the new environments.
Let me just
Of course.
add to that real quick,
Yes.
because that's also a new angle in the recent IPCC report, the term of maladaptation, right? In all our efforts to make a system more climate resilient and climate smart, it's really important to have a holistic view on all sorts of impacts. You know, it's easy to say, oh, let's shift planting dates and use a new cultivar, but then what happens if late frost comes in and and has adverse impacts on your field? So the idea of maladaptation should really be taken seriously, and that's where the models and the local expertise has its limitations, because the models aren't perfect, and that's another call for using the models in a way that we can reduce the uncertainties.
Thanks, Jonas. Thanks, Stefanos.